Welcome students. We are discussing the problems on work energy power from the constant physics book. So let us continue with our discussion. So today we will be solving another two set of problems. Let us see what does the first problem says. Now the first problem says a figure has been given and it is said that a block A weighing 100 Newton is pulled up a slope of length 5 meter by means of a constant force 100 Newton. Fine, as it has been shown in the figure. So the first part of the question asks that what is the work done by the force in moving the block A 5 meter along the slope, and second part of the question is that what is the increase in the potential energy of the slope, whereas the third part of the problem says that account for the difference in the work done and the increase in potential energy. Okay, fine. So first of all, let us write the given informations. So solution number 1. So what are the given informations? First of all, it has been said the weight of the block. Okay, the weight of block can be taken as m into g. Okay, and this is given as 100 Newton, isn't it? Okay, fine. Then the next thing, the length of the slope. Length of slope has been given as 5 meter. Okay, and the height up to which the block has been raised is given as 3 meter. Okay, so just check it once. So this has been the figure. Okay, and also the force that has been applied to move the block up the slope is 100 Newton. So force applied is also 100 Newton. Force applied, let us consider it as F. This is also 100 Newton. Okay. Now it has been asked, the first part of the solution has been asked that what is the work done by the force in moving the block up the slope. So coming to the first part of the problem, work done by the force. So work done by the force. Okay, so what is the value? Work done by the force, it is equal to, so you can write it as Fs cos theta. So Fs cos theta, isn't it? So the force F has been applied as 100 Newton. S displacement is 5 meter along the slope, and as you can see, the displacement and the force applied in the same direction, so cos 0 degree. Now this turns out to be total, but it is 100 into 5 meter length and cos 0 degree. So this turns out to be 500 joule. Okay, 500 joule. Fine. So you have obtained the answer for the first question, first part. Okay. Now let us come to the second part. Second part says that what is the gain in potential energy or increase in potential energy. See, second part of the question says what is the increase in potential energy. So you can say that the increase in potential energy is given by the formula mgh. Okay, so increase in potential energy. So h is this height h, length of the slope was the displacement s. Okay, fine. So increase in potential energy is given by the formula mgh. So I think you can easily understand that as weight of the block has been given, and that is actually equal to the value of m into g. So you can directly put the value of m into g as 100, and the height h that has been raised is into 3. So this turns out to be 300 joule. So 300 joule is the answer. Second part. Now third part says account for the difference in the work done and the potential energy gained or increased. So why this what does it is what is actually meant by this term, by this question? Actually see, when we do work on any body and move it very slowly, the work done on the body is converted into potential energy of the body. That is the main fact. Now here, what we can see is that the increase in potential energy you can say that the increase in potential energy is 300 joule, whereas the work done has been 500 joule. So, but we have done actually the increase in potential energy should also have been 500 joule, but it is not so. So, actual increase in potential energy is 300 joule, but you have to do some extra work. So, why is this difference coming? So, actually, the difference is I can calculate as the difference is how much is the difference? 500 minus 300. So this turns out to be 200 joule. Why this difference? Now this difference is due to the friction. So this difference is due to the, it is due to friction. It is due to friction. Okay. So we can say, okay. So this difference is actually due to the friction on the slope. Okay. The difference is due to the friction on the slope. So it is due to the friction on the slope, because a part of the work that is done is taken up in overcoming the friction. So this is a mechanism for the difference. So this is the solution to the problem number 1. Now let us quickly move on to problem number 2. Just let me check out what the problem number 2 is all about. So problem number 2. Okay. So what is the problem number 2 given about? It is said that a body of mass 60 kg has a momentum of 3000 kg per meter second. So given information is mass and momentum. From that you have to calculate the kinetic energy and the velocity. So we can write as given. What are the two things given? The two things that are given are, one is the mass of the body. Let us consider it as m. Let us consider it as m. It is 60 kg. Okay. And the second thing that has been given is momentum. Okay, momentum. So momentum is denoted by the letter symbol P. It is given as 3000 kg meter second inverse. Okay, meter second inverse. Fine. Okay. Now we have to find out the kinetic energy. Now can you relate the momentum to kinetic energy? Okay. For that, let us see, just I am doing a little analysis. You know that kinetic energy is equal to half mv square. You don't need to do this in your copy. You just need to put the relation between the kinetic energy. But I am just showing it for your better understanding. And momentum is given by mass into velocity. From the expression of kinetic energy, can you write that the value of the velocity is 2 into kinetic energy by mass, isn't it? 2 into kinetic energy by mass. Okay. Now from here you can say that the momentum P, to the value of the kinetic energy, value of velocity here, P is equals to m into root under of 2 into ke by m, isn't it? If we just put this m into the square root, then it will ke into m square, isn't it, by m. So this turns out to be 2 km. So momentum P is given as root over of 2 ke into m, that is the mass. Or we can also write it as kinetic energy is equals to P square by 2m. Okay, fine. So the for the first problem, we have to, momentum has been given, we have to find out the kinetic energy. So actually we will be using this formula, isn't it? We will be using this formula. So just move on to the next page. So kinetic energy equals to P square by 2m. Kinetic energy is equal to P square by 2m, isn't it? So P square means 3000 kg meter per second. So 3000 into 3000 by 2 into mass means 60 kg. So this is the formula. Okay, 6 5 is 30, 50, and here 225 is okay. So it turns out to be 75, and then 3 zeros, 75,000 joules. So this is the value of the kinetic energy. Okay. So first part of the problem is already done. Let us move to the second problem. Second part says that find out the velocity. Okay. So we know that kinetic energy is actually equal to half m v square, isn't it? So you can say that v square is equal to 2 into k by m, isn't it? So 2 into k, 2 into, you can write 75000 by mass m is 60. So 230 is a 60, 10 cuts out, and this turns out to be 2500. Therefore SPV is equal to root under of 2500. So this turns out to be 50. Hence the velocity is 50 meter per second. Hence the velocity is 50 meter per second, not 50 meters in inverse. So this is the solution. So I hope the problems are very clear to all of you. So today we will be ending our class here. In the next class we will be continuing some with other some problems, some difficult problems. Let us hope. Till then, take care. Goodbye. Thank you.